So here we are, our new chapter in physical equilibria, which we are calling steam distillation. We are calling it steam distillation. Shamila, can you read for us the definition of steam distillation?
Steam distillation. Steam distillation is a technique of separating a volatile substance immiscible with water at a temperature below its boiling point from another substance by bubbling steam through the hot mixture.
So what happens during steam distillation? During steam distillation, we have a volatile substance, but which is immiscible with water. If you are to remind me, you have already seen examples of substances that are immiscible with water. Can you remind me those substances? I'm to give you one, benzene and water. These ones are immiscible. Can you remind me others?
Paraffin and water.
Paraffin and water. Yes, Trisha.
And water.
Yes, Trisha. Yes, Ali.
Trichloromethane and water.
Trichloromethane and water. Another one.
Tetrachloromethane and water.
Tetrachloromethane and water. Another one.
Mercury and water.
And water.
And so many others. Now, a mixture of these ones with water can be purified or separate from its other impurities by a process called steam distillation. What do we do during steam distillation? The word steam distillation comes from these two words, steam, which is gaseous water. To distill is to vaporize a liquid mixture and get off that component that boils at a higher temperature, go on collecting others and others until you obtain a pure separate liquids. Now, when you have benzene and mixed with some other impurities, what do we do? What we do is to add water to mixture of benzene and the other impurities, which water is added to that mixture in form of steam. The steam is bubbled through the liquid mixture containing the other liquid impurities and benzene. But that substance we are separating from the other impurities must be volatile. It must be what? Volatile. Okay? And remember,
Yes.
that the separation occurs. Why do we bubble air steam? Such that we make it sure that the vaporization occurs at a temperature or that of benzene and water. Remember, we have just said that benzene boils at 80, water boils at 100. And the mixture, when steam distilled, will boil at a temperature lower than the boiling point of either of the two liquids. So that brings to us the definition of steam distillation, which we are saying that it is the, Shamila, read it again.
Steam distillation is the technique of separating a volatile substance immiscible with water at a temperature below its boiling point from another substance by bubbling steam through the hot mixture.
Let me hope somebody will never forget that definition. So what happens during steam distillation? The volatile substance to be separated vaporizes off with the steam, leaving behind the non-volatile substance. And steam distillation depends on properties of immiscible liquids. That's why we are saying that the volatile substance to be separated from its impurities must be immiscible with water. This process is usually used to extract organic substances with high boiling points that decompose on heating and cannot be distilled at atmospheric pressure. Some of you are going to become pharmacists. Have you heard of what we call Covidex?
Yes, teacher.
Now, Professor Gwanga, the manufacturer of Covidex, extracted that herb he's using to make Covidex from a given plant whose name I have forgotten. But he could have used the steam distillation to obtain a pure active substance in that those leaves. So what he went to a bush, collected the leaves, all the stems. When he collected the leaves, he must have dissolved them in water and oiled. Get now a liquid, in which liquid has the active substance you want to extract. So to extract this active substance, I don't know whether it was immiscible with water or immiscible, but one of the procedures that can be used to get that component is steam distillation, if you want it in its pure form. So some of these principles are applied in pharmacy, pharmacology, and other procedures. There's something we call the principle on which steam distillation is based. They can ask you to explain the principle on which steam distillation is based. This is what we have already seen previously. It has basically these 4 points that you're seeing me giving here. First of all, the 2 components must be immiscible. And that immiscible liquid mixture must be either agitated or heated, such that each of the liquids in the mixture exerts its vapor pressure independently of any other liquid in that mixture. Are we together?
Yes, teacher.
So there must be 2 immiscible liquid mixtures that are heated, such that each of the liquids exerts its own vapor pressure independently. When that happens, the vapor pressure above the liquid mixture is the sum of the vapor pressures of the 2 components. On continued heating, both the vapor pressure of each liquid and the total vapor pressure above the liquid mixture increases. The mixture will then boil when the total vapor pressure is equal to the atmospheric pressure at a temperature below the boiling point of the 2 components. So that principle, if I'm to award, it will give you 4 marks. Am I very clear?
Yes, teacher.
Can any of you repeat for me the principle of steam distillation? What are the key points in the principle of steam distillation? Who is ready to give me that principle on which steam distillation is best? Why only Ali? Is he the only person I have in class right now? Okay, you Ali. Ali?
Yes, teacher. Yes, teacher.
Yes, your hand is up.
You talked about the principles and I'm now giving them. The component mixtures must be immiscible.
You're not giving, you're describing. I want you to describe, you're not giving points here. So I want you to say that when an immiscible liquid mixture. I want you to do that
Okay.
form. Yes. Go on.
When an immiscible liquid mixture is heated or agitated, forms gives a vapor. Teacher, I thought you wanted to describe to list down the principles.
People call them principles, but it's one principle that you're explaining. Although people confuse them by calling them principles. They can tell you to
Okay.
explain the principle of steam distillation. You're not outlining, but you're
Okay.
explaining.
I'm continuing now, sir.
Mm.
It said that when a miscible liquid mixture heated or agitated, each of the liquid components.
Mm. Go on.
Each of the liquid components gives an independent vapor pressure
Gives an independent vapor pressure. Mm.
in the atmosphere.
Such that
the total vapor pressure of the mixture
the total vapor pressure above the mixture or exerted by the mixture
is equal to the individual vapor pressures of the components.
is equal to the sum. Is equal to the what?
To the sum
Of the individual vapor pressures. Go on.
When the mixture is continued heating,
On continued heating. Mm.
The temperatures of
Continued
individual
on continued heating.
On continued heating, the temperatures, the vapor of each independent component of the mixture increases.
On continued heating or agitation, the vapor pressure of what?
Of each
component.
Of each component of the mixture increases.
Increases. And also
the total vapor pressure of the mixture.
And also the total vapor pressure increases.
Of the mixture increases, such that the mixture boils at a low
until the total vapor pressure.
Until the total vapor pressure is equal to the atmospheric.
Very good. It's equal to the atmospheric
pressure.
And the
mixture boils
will boil
at a low vapor pressure.
At a lower temperature than
at
boiling point.
At a low temperature than
boiling point of either liquids or either components.
Yes.
So that's what is called the principle of steam distillation, or the principle on which steam distillation is based. Are we together?
Yes.
Yes.
Okay. If that's fine, we are almost concluding the lesson. We should go through the process of purification of a liquid mixture by steam distillation. How do we purify a liquid mixture by steam distillation? So during this mixture, we get the impure mixture containing that substance we want to steam distill. And then when we get that liquid mixture, we heat it. We heat it and then pass steam through the heated mixture. So here they are telling us that they want us to explain how. Okay, you're given the boiling point of phenylamine, 184, and then you're told that the mixture of phenylamine and water boils at 98. Describe how an impure mixture of phenylamine can be purified by steam distillation. So what we do first is to heat the impure mixture containing phenylamine. And as you heat it, you bubble steam through that heated mixture at a temperature. This temperature here, which is given in the equation, at that temperature and 1 atmosphere, which is the normal atmospheric pressure. Remember, we said that boiling takes place when the vapor pressure above the mixture is equal to the atmospheric pressure. Are we together?
Yes, teacher.
So, which is 1 atmosphere. So at that temperature, 98 degrees Celsius and 1 atmosphere, a mixture of water and phenylamine distills off. The distillate, which is 2 separate layers containing phenylamine and water, is collected in the receiver. Then the phenylamine is separated from the water in the distillate by using a separating funnel, and then it dried using any suitable drying agent. Are we together?
Yes, teacher, we are
Don't want it
together.
to separate. That's the simple procedure that you want to describe. So if it's a general procedure, what do? You say the impure mixture containing the component to be distilled off is heated. Steam is passed through the heated mixture. Then at a temperature at which that liquid mixture boils and at 1 atmosphere, a mixture of water and the component to be distilled off is collected in the receiver as 2 separate layers. Then the component to be distilled off is separated from the water using a separating fan and then dried using a suitable drying agent. Then you draw a setup of the apparatus to show that the steam is bubbled through from what we call a steam generator to the mixture containing the substance to be distilled off and the impurities, which must be heated. So the result is water here in the what? How do we call this apparatus here? Condenser. So introducing cold water, it cools that steam containing the volatile substance, which is in this case is the aminobenzene. As it cools it, the warm water gets off. The distillate of water and aminobenzene is collected here. And then you can purify this mixture, or you can separate the 2 components using solvent extraction, which we shall see later in our next topic. If you don't use solvent extraction, you can use a separating funnel to separate the 2. Are we together, members?
Yes, teacher.
So mixture of 2-nitrophenol and 4-nitrophenol can also be separated by steam distillation, as we have described before, aminobenzene or aniline above. Why is that possible? 2-nitrophenol boils at 214 degrees Celsius, 4-nitrophenol boils at 279 degrees Celsius. So what do? We get a mixture of 2-nitrophenol and 4-nitrophenol. And in that mixture, we are aware that 2-nitrophenol has a lower boiling point. Why does it have a lower boiling point? Remember what we call intramolecular hydrogen bonding. We explained that in our topic, bonding and structure. So the 2-nitrophenol, which has a lower boiling point than the meta-substituted isomer, which is 4-nitrophenol, will distill off with the water and collected in the receiver. So the distillate is shaken with ether, which dissolves the 2-nitrophenol, and then the 2-nitrophenol is then separated from ether by steam distillation. So by understanding this, I want someone to explain it to us how we can purify a mixture of 2-nitrophenol and 4-nitrophenol by steam distillation. No diagram required. Who is able to explain that or to describe that? Who is able to describe that?
Pardon, teacher, the question.
The question is, describe how a mixture of 2-nitrophenol and 4-nitrophenol can be purified by steam distillation. Or how we can collect pure 2-nitrophenol from a mixture of 2-nitrophenol and 4-nitrophenol.
Teacher,
Can I take it through? Can I go through it again with you?
yes, teacher, more one time.
So this is what we should say. We should say a mixture of 2-nitrophenol and 4-nitrophenol is done what? Is heated.
Is heated.
And the steam is bubbled
through the heated mixture.
mixture. These are very simple things. They make chemistry very enjoyable. Steam is bubbled through the heated mixture.
At a certain temperature.
Then at a temperature, which we are not going to specify here because we don't know the boiling point of each of these, at a temperature lower than the boiling point of water,
and
a mixture of 2-nitrophenol. Remember, 2-nitrophenol has the lower boiling point, and water distills off, condensed, and then collected in the what? In the receiver. You get it?
Yes, teacher.
Okay. So if you collected it in the receiver, then you have to purify the mixture by getting off the 2-nitrophenol from water. Remember, this one is now remaining as the what? The residue. Are we together? Because it's an impurity, we don't want it. Are we together? In the
Yes,
receiver
teacher.
as distillate. 4-nitrophenol remains as the residue. Are we together? So our 4-nitrophenol remains as residue. Then you say the 2-nitrophenol is then purified from water or collected from water by solvent extraction or removed using what? A suitable drying agent, not so? Or what other method do we say? Or separated using a separating funnel. You can choose any of the three methods. or any other suitable one. Don't you see that this is very simple? Say it is heated, you get half a mark. Steam is bubbled through the mixture, get that mark. You may tell us where the steam comes from, maybe from a steam generator, in case you don't have the diagram. If the diagram is not required, don't draw it. If it's required, then draw it. At a temperature lower than the boiling point of water, a mixture of 2-nitrophenol and water is distilled off, condensed, collected in the receiver as distillate. Nitrophenol remains as residue. The 2-nitrophenol is then purified from water by solvent extraction. I've told you choose any of those methods. The diagram may earn some good marks, so you also include it. Ali, you have a question?
Yes, teacher.
Ask very fast. Time is against us.
Teacher, in our mixture, we have 2-nitrophenol and 4-nitrophenol. So
Yes.
this steam, the steam we are using is not, the water we are using to get steam is not mixed within the two components of the mixture.
It is not part of the components. If you remember the definition of steam distillation, we are collecting a volatile component from its impurities. Okay? So the water comes in as a
Yes.
third component. Are we together?
I'm not getting you, sir.
Water comes in that mixture to be purified as a third component. Do you remember the definition of steam distillation?
I remember, sir, because you talked about the steam. To me, now I'm understanding it as I get now the 2-nitrophenol and the 4-nitrophenol into a certain thing like then I use steam to heat it.
Okay, listen to me.
Okay, teacher.
Can you read this definition again? Ali,
Yes, teacher, I'm not seeing it on my screen here.
are you now seeing it?
Not yet.
Even now,
Yes, I can see. I'm seeing it now, sir.
read the definition.
Steam distillation is the technique of separating a volatile substance immiscible with water at a
Maybe what I
temperature
can
below
add
its
here,
boiling.
technique of separating a volatile substance from its impurities. Okay?
Yes, teacher.
Separating a volatile substance from its impurities, immiscible with water at a temperature below its boiling point. Actually, it's already indicated here. I don't need to put this. Separating a volatile substance immiscible with water at a temperature below its boiling point from another substance. So the volatile substance we are separating must be with another substance. That other substance now what we call the impurity. Are we together?
I'm getting you now, teacher.
By bubbling steam through the mixture. Now that volatile substance will be separated, vaporizes off with steam, leaving behind the non-volatile substance. Have you got the concept?
Yes, teacher.
I think I'm now clear.
Yes.
Now we conclude by the conditions necessary for steam distillation. What are those conditions? The substance to be purified by steam distillation must be immiscible or insoluble in water. It must have a high relative molecular mass such that a very high amount of it vaporizes off with steam. It must exert a high vapor pressure at 100 degrees Celsius such that a very high percentage of it is collected in the vapor. Any impurities present in it must be non-volatile so that they don't go off with the steam. Are we together? Those are the four
Yes, teacher.
conditions necessary for steam distillation. What are the advantages of steam distillation? There are basically two advantages. One, it's able to purify substances that decompose at temperatures near their boiling points. The substances to decompose near its boiling point, then the best method to use is steam distillation to purify it. Distillation takes place at a lower temperature than during fractional distillation. Thank you for attending the lesson. Subscribe to our YouTube channel for more of these lessons. We meet next time. Thank you so much.
Thank you, sir.